Swayam Prabha. Digital India. Educated India.
Hi everyone, welcome to the lecture number 10 and the second lecture on labor demand. In the long run, the farm's capital stock is not fixed. So, the farm can expand or shrink its plant size and equipment by adjusting all the factor inputs. So, in the long run, the farm maximizes profits by choosing both how many workers to hire and how much plant and equipment to invest in. Now, in this lecture, we will discuss about the long run demand curve. So, how the farm takes a employment decisions in the long run. Here, we have taken a production function that output is a function of both labor and capital, and since it is a long run is a phenomena where all the inputs are variable. So, any change in the output can be come through the change in the employment and change in the capital. So, the farm can produce any given level of output with different combination of this labor and capital. So, let me explain through a graph. If the farm decides to produce Q0 amount of output, the farm is having so many combinations of labor and capital to produce this level of output. So, if you compare this point x, the farm can employ this much of capital and this much of labor to produce this Q0 amount of output. The farm can up to operate at point y, means employing this much of capital and this much of labor. The farm can go for the combination which is at point z. The farm can employ this much of capital and this much of labor. So, in the long run, the farm can take a decision that how much of output he can produce with different combination of factor inputs. So, if you join these points, you will get that this is that different combination of factor inputs can produce same level of output, and this curve is called the isoquant. So, higher and higher level of output can be produced with higher and higher combination of both labor and capital. So, if you see Q1 level of output can be produced at higher combination of labor and capital. So, these are called the isoquants, and these isoquants describe the possible combination of labor and capital that produce the same level of output. If you look at the properties of these isoquants, they are quite similar to the properties of the indifference curve. The isoquants must be downward sloping because of this diminishing return. The isoquants, they do not intersect, they should not intersect with each other. Higher isoquants are associated with higher level of outputs. So, Q1 produces higher level of output as compared to Q0, and isoquants are convex to the origin. So, they are downward sloping, they do not intersect, and higher isoquants associated with higher level of output and they are convex to the origin. So, these are the properties of the isoquants. Now, if we want to find that what will be the slope of these isoquants, what exactly happens when the farm move from point x to point y. So, when the farm moves from point X to point Y. Now, the farm is substituting this much of capital by this much of labor in order to produce Q0 level of output. So, the slope of this isoquant at each point is nothing but it is the change in capital, change in employment. So, the technical term is called the marginal rate of technical substitution. The absolute value of this slope of this isoquants is called the marginal rate of technical substitution. And this marginal rate of technical substitution is nothing but this delta k by delta E is nothing but is the ratio of this marginal product of labor by marginal product of capital. Now, the farm can produce different level of output by employing different level of factor inputs. Now, in order to produce, the farm has to bear certain cost. So, the farm is going to employ labor and the farm is going to employ capital to produce a fixed level of output. So, the total cost for the farm is nothing but cost towards the labor and cost towards the capital. Now, this is the total cost function for a farm. If the farm is having some amount of money to spend on these two factor inputs, then farm has to choose that how much labor should be hired and how much of capital should be employed. If the farm is going to spend this entire money on labor, making this capital 0, then this farm should hire this much of labor. Here on this x axis we have taken number of employment the farm can hire, on the y axis we have taken the amount of capital the farm can employ. So, if the farm is going to spend his entire money on this labor, then the farm will employ this much of labor. If the farm is going to employ his entire money on capital, then the farm will hire this much of capital. If you join these 2 points, then you will find that any amount of labor and capital the farm can hire on this point. So, this is the farm's iso cost function or the cost function. So, the technical term is called iso cost. So, any point on this it is achievable. The farm can have different combination of capital and labor in order to produce a certain amount of output. If you want to find the slope of this iso cost, then it is simply the W by R. So, the slope of this iso cost line is simply the ratio of input prices. Now, if you rearrange this cost function C equals to W e plus R k, then you can rewrite it k equals to C by R minus W by R e. So, here W by R is the slope and C by R is the intercept. So, the slope of this iso cost line is W by R. Now, let us try to find out how the farm finds that optimal combination of these factor inputs to be employed in order to produce a fixed level of output. So, the farm's optimal combination of factor inputs, here we have considered the cost minimization method. We have fixed the level of output. The farm decides that it will produce Q0 amount of output. Now, to produce this Q0 amount of output, what is the least cost function on which he can operate? So, there could be different cost functions. When we superimpose this output production function over this cost functions, we find that the farm can employ 175 units of capital and 100 units of labor in order to produce Q0 level of output, which will maximize the profit and minimize the cost. So, this much of capital and labor combination is going to give him the profit maximization to produce this level of output. So, the profit maximization condition is nothing but it is the MPE by MPK equals to W by R, or MPE by W equals to MPK by R. So, it is nothing but it is the slope of the isoquants equals to the slope of isocosts. MPE by MPK is nothing but the slope of isoquants, and W by R is nothing but the slope of the isocosts. The tangent point of this slope isocost and isoquants is the solution point for the profit maximization of the farm to produce Q0 level of output. So, if you look at here MPE by MPK, this side is talking about that what is the revenue that the farm is going to get, and W by R is the cost, per unit cost what the farm is going to have. So, when the per unit revenue equals to per unit cost, that is the point where the farm maximizes its profit. So, the farm will employ this much of capital and this much of labor and will operate at point P. If you compare with point A and point B, the farm can produce same unit of output by operating at point A and point B, but this is going to have a higher cost. Point A and point B lies on a higher isocost function. So, A and B are definitely going to be costly to produce same unit of output as compared to point B. Here, the last worker hired produces the MPE units of output for the farm at the cost of W dollar. So, at point P, the last worker hired produces MPE units of output for the farm at a cost of W dollar. If the marginal product of labor is 20 units and the wage is 10, then the ratio, this MPE by W, implies that the last dollar spent on labor yields 2 units of output. Similarly, the ratio of MPK by R gives the output yield of the last dollar spent on capital. So, the cost minimization requires that the last dollar spent on labor yield as much output as the last dollar spent on the capital. In other words, the last dollar spent on each inputs gives the same return. So, the hypothesis that the farm minimize the cost of producing a particular level of output is often confused. With the hypothesis that the farm maximize profit, it should be clear that if we constrain the farm to produce Q0 units of output, the farm must produce this level of output at a cost minimizing way in order to maximize profit. So, the profit maximizing farms therefore will always use the combination of labor and capital that equates the ratio of the marginal products to the ratio of the input prices. So, this condition alone, however, does not describe the behavior of the profit maximizing farm. After all, this equality of ratios in equation was derived by assuming that the farm was going to produce Q0 unit of output regardless of any other consideration. So, a profit maximizing farm will not choose to produce just any level of output, Rather, a profit maximizing farm will choose to produce the optimal level of output, that is the level of output that maximize profit, where the marginal cost of the products equals to the price of the output. Therefore, the condition that the ratio of marginal product equals to the ratio of prices, it does not tell us everything we need to know about the behavior of the profit maximizing farm in the long run. We saw earlier that for a given level of capital, including the optimal level of capital, the farm's employment is determined by equating the wage with the value of the marginal product of labor. So, by analogy, the profit maximizing condition that tells the farm how much capital to hire is obtained by equating the price of capital R and the value of marginal product of capital. Therefore, the long run profit maximization also requires that the labor and the capital to be hired up to the point where this wage equals to the value of marginal product of labor and the interest equals to the value of marginal product of capital. So, these profit maximizing conditions imply the cost minimization. We can now determine what happens to the farm's long run demand for labor when the wage changes. We initially considered a farm that produces Q0 units of output. We assume that this output is the profit maximizing level of output, in the sense that at that level of production output prices equals to the marginal cost. So, a profit maximizing farm will produce this level of output at the lowest cost possible. So, it uses a mix of labor and capital, where the ratio of marginal products equals to the ratio of input prices. Now, let us try to see that what is going to happen, the employment decisions of the farm, if there is a change in the wage rate. Here we have considered there is a decline in the wage rate, holding the constant initial cost outlay at C0. So, we are assuming that the total cost outlay C0 is constant, and if there is any changes, any reduction happens to the wage rate, how the employment decision is going to change. If you look at this graph, on this x axis we have taken employment, on the y axis we have taken capital, and different combination of this labor and capital can produce a fixed level of output. So, initially the farm is producing, let us say, Q1 level of output with the given wage rate W0, and the ISO cost line is this, and the production ISO quants this. So, the farm is operating at point P, means profit maximizing condition gets satisfied at point P. The farm is employing 75 units of capital and 25 units of labor. Let us say this is the initial situation for the farm. Now, the wage has reduced. So, when the wage is reduced, definitely the opportunity set for the farm will increase. Now, the ISO cost line shifts from here to here, and the condition gets satisfied, profit maximization condition gets satisfied at point R. The farm is operating at a higher ISO quant Q0. So, now the farm has moved from point P to point R, the employment has increased. When we are doing this kind of exercise, we have to be extremely careful when we are drawing this new ISO cost line, because the obvious way of shifting this ISO cost line is also the wrong way of shifting it. As we have seen in the figure, we may want to shift the isocost by rotating it around the original intercept, which is C0 by r. If this rotation of this isocost line were legal, then the farm would move from point P to point R, and this wage reduction increases the farm's employment from 25 to 40 workers, and there will be increase in the output from Q1 to Q0. Although we are tempted to draw it, the way it has been drawn in the figure, the analysis is simply wrong. Why? The rotation of the isocost around this original intercept implies that the farm's cost outlay is being held constant at C0 $. However, there is nothing in the theory of profit maximization to require that the farm incur the same cost before and after the wage change. So, the long run constraints of the farm are given by the technology and by the constant price of the output and other inputs. So, in general, the farm will not maximize its profit by constraining itself to incur the same costs before and after the wage change. So, you will not rotate around that initial cost outline at that intercept. So, if we are doing this, we are rotating around this intercept, simply moving this iso cost from this position to this position, then it is simply a wrong analysis. What is the impact of wage reduction on the output and employment of a profit maximizing farm? Will the farm expand if the wage falls? So, the decline in the wage will typically cut the marginal cost of the farm, which means it is cheaper to produce an additional unit of output when the labor is cheap than the labor is when it is expensive. So, we then expect that the drop in the wage rate would encourage the farm to expand production. Now, what happened when there is a reduction in the wage? The marginal cost, earlier it was this, now it has declined. So, a declining marginal cost will induce the farm to produce more. So, definitely the farm will move from earlier this isoquants where the output level was 100, now it will move to a higher isoquant where the output level is 150. Now, the point here is that to produce this level of output, the farm will find a different combination of factor inputs which has to be employed in order to maximize profit this level of output. So, it will not rotate around this point. So, the farm will have a different combination of factor inputs based on this cost function. So, his total cost function is going to change. Because the marginal cost drops, the wage cut encourages the farm to produce more output. Therefore, the farm will jump to a higher isoquant. So, the total cost of producing this 150 units of output need not be the same as the cost of producing 100 units earlier. So, as a result, the new isocost line need not originate from the same point, as I have said. We know however, that a profit maximizing farm will produce 150 units of output efficiently. That is, this output will produce using the cost minimizing mix of both labor and capital. So, the optimal mix of these inputs therefore is given by the point on the higher isoquant where the isoquant is tangent to the new isocost line. So, the slope is W1 by R, and it is flatter than this original isocost line. So, the solution is given by point R. So, as shown in the farm's employment decision, which has increased from 25 to 50 workers in the graph, we can see the farm will always hire more workers when the wage falls. So, the positioning point R in the figure also implies that the farm will use more capital, but this need not always be the case. In general, a wage cut can either increase or decrease the amount of capital demanded. So, if you draw the relationship between the decline in the wage and the amount of employment which happens in the long run, you will find that now a decline in the wage has increased the employment from 25 to 50. So, the long run demand curve for a farm is always downward sloping. In our derivation of workers labor supply curve, if you remember, we decompose the impact of wage changes on hours of work into the income and substitution effect. Here also we can use the similar decomposition to assess the impact of wage change on the farm's employment. The wage cut reduces the price of the labor relative to that of the capital. So, the decline in the wage encourages the farm to readjust its input mix so that it is more labor intensive. Now, the farm takes the advantage of this new cheap labor. In addition, the wage cut reduces the marginal cost of the production and encourages the farm to expand. So, as the farm expands, it wants to hire more workers. There are two effects works when there is a wage cut. One is the scale effect, another one is the substitution effect. So, now let us try to understand these two effects through this graph. On the x axis we have taken employment, on the y axis we have taken capital, and we are trying to find out that what is the optimal combination of factor inputs the farm should employ in order to maximize profit. So, the initial condition, the farm was fixed its production 100 units. To produce 100 units of output, the farm was employing 25 units of labor. Now, the wage rate has declined. Because of the reduction in the wage rate, the isocost line shifts and the farm produces, because of the marginal cost decline, the farm produces higher level of output. To produce 150 units of output, the farm is operating at a new isocost line, and this new isocost line is tangent to this isoquant at point R. So, the farm has moved from point P to point R. Now, the farm has moved from employing 25 labor to 50 labors. So, this movement from P to R happens through Q. So, this effect from P to R is this total effect, is a combination of the scale effect and substitution effect. Now, the wage has reduced, the marginal cost has declined, so as the farm is induced to produce more, so as the farm is to employ more worker. So, if we want to find out what is the scale effect, there is a increase in the scale of production. So, how much is due to the increase in the scale of production, increase in the employment? We have drawn a parallel line DD to the previous cost function and it get tangent at point Q. So, moving from point P to Q, as the wage reduced, the farm employs more labor from 25 to 40. This is the scale effect, because the cost of the production has gone down, the farm is producing more, he has to employ more worker. Now, while producing this 150 units of output, the farm finds that labor is cheaper as compared to the capital. So, the farm moves from point Q to R by substituting capital, this much of capital, by adding this much of labor. So, movement from P to Q is the scale effect. Moving from Q to R, the farm is adding another 10 workers because of this substitution effect. So, as a result, we can see the farm employed 50 workers, 20 to 40 is because of the scale effect and 40 to 50 is because of the substitution effect. So, the scale effect indicates that what happens to the demand for the farm's input as the farm expands production. As long as capital and labor are normal inputs, the scale effect increases both the farm's employment and the capital stock. However, holding the output constant at 150 units, the farm adopts a more labor intensive input mix. Now, the farm is substituting and moving away from the capital towards labor. So, the substitution raises the farm's employment from 40 to 50 workers. Both the substitution effect and scale effect induce the farm to hire more workers as the wage falls. As you can see in the figure, it indicates that the farm hires more capital when the wage falls, so that the scale effect outweighs the substitution effect. So, the scale effect which increases the demand for capital outweighs the substitution effect which reduces the demand for capital. The farm would use less capital if the substitution effect dominates the scale effect. This is all about the long run demand for labor, how the farm demands labor in the long run. So, we have seen that the long run demand for the labor is also downward sloping, as it was in the case of short run demand for labor. In the next lecture, we will discuss about the demand elasticity, labor demand elasticity, how we measure this elasticity and what is the use of this labor demand elasticity in the policy applications, both in the short run as well as in the long run. Thank you.